Hello, yeah, in this video, I want to show you two approaches for performing exploratory factor analysis for ordinal data using R. And as you know, ordinal data is very useful. For example, when you collect data using a questionnaire, you may use Likert scale. Okay, so that will lead to ordinal data. Okay. But we also know ordinal data is tricky because not only they are categorical, but also those categories have a underlying built-in order. Okay, so the statistical method we use to analyze ordinal data must take into account of that underlying ordered structure of the data. Okay. So the first approach I want to show you need three libraries: mass and psych and Polychoric. Okay. So let me load in this three library and set a random seed. First, I want to create a synthetic data set with 500 observations, 5 variables, and I need to create a loading matrix, which I use to create a correlation matrix. And then I create a latent data matrix by randomly sampling from a multivariate normal distribution with mean 0, and the sigma, the correlation matrix, is R. Okay. So why do we need this latent data matrix? Okay, so this approach has an assumption that the ordinal data we observe actually come from some underlying latent continuous random variables. Okay, so we have these underlying latent continuous variables, and also we have thresholds, and we cut these latent continuous variables as their thresholds, and we get ordinal data. So that is the assumption we imply in this approach. So let's specify thresholds for 5 variables, and then we cut the original latent continuous variable at these thresholds to get ordinal data, put them together, name them as the V1, V2, V3, V4, and V5. Okay. So this is what it looked like, the first few rows. Okay. And now we go to factor analysis. And this approach is really based on the idea that we don't need the raw data to perform a factor analysis. We just need the correlation matrix. Okay. So even though we have ordinal data, as long as we can calculate a correlation matrix for the ordinal data, then we can feed it to the factor analysis function to perform a factor analysis. Okay. So here we use the Polychoric function in the Polychor package, and it does calculate a correlation matrix for ordinal data, and its output consists of a list, and we need to track the RHO rule. That's our correlation matrix. Okay. And after we have that correlation matrix, we can feed it into the FA function, which is the factor analysis function in the package psych. And you need to specify n factors, number of factors. Here, let's try 2. The estimation method is mean RES, the minimum residual. And then the rotation method is oblique mean. Okay. I will leave it to you to read the documentation of FA to learn about more details about these options. Okay. So let's run the factor analysis. Very quick. Takes no time. And then let's print out the results. You can see it has a lot of results here, starting with the variables and the MR1, MR2 are the factors. You got the loading. And then H2 is the commonality. That's the sum of the explained variance from each and every factor. So it is kind of the variance explained by this factor model of that V1 variable is 50%. U2 is called uniqueness. It's just 1 minus H2. Okay, so the closer H2 to 1, the better the factor explaining the variance in the variable. Okay, the COM is the complexity. This is if it's close to 1, that means these factors explain the variable really well. But it's larger than 1, then it means you may need additional factors or higher order factors to explain more variance. So here we get 3 ones and 1.3, 1.7. Looks like V3 need more factor to explain. Okay. And the next one, the table, I think the most important one here is the accumulative proportion. So with MR1, we get 61% variance explained. With MR1 and MR2, we get 100% variance explained. So we did a very good job by when we selected 2 factors. Okay. And then there's the factor correlation. So MR1 and MR2 are correlated positively with the correlation coefficient of 0.49. So it's like a median correlation. The mean item complexity 1.2. So it's close to 1, but not quite. So maybe acceptable. And then the test of hypothesis that 2 factors are sufficient. That means our two-factor model is good by the hypothesis test, but somehow I didn't see p-values and other test statistics for this hypothesis test, and I didn't really look into the documentation to see how we can extract that information. Okay. Degree of freedom of null model. A null model is the baseline model where we assume there's no correlation among the variables. So basically there's no redundancy in the data set, so we don't have any factor to extract. We don't need to do a factor analysis. Okay. So here we say there's a degree of freedom for the null model would be 10, and then the objective function, again I don't have the formula for the objective function, is 1.85, so we view this as a baseline value. And then the degree of model as degree of freedom is 1, then the objective function is reduced to 0.1. So we have a model with only 1 degree of freedom. That means there's one extra parameter to be estimated. So we have almost like a very saturated model, but the objective function is not 0.1, so it's really much smaller than 1.5. So this is good, but on the other hand, we only have 1 degree of freedom left, so we don't have much room to improve. So good or bad, this model, the two-factor model. So from this angle, okay. And then when you work with factor analysis, factor models or structural equation models, you will get like a list of model fit statistics, indices. Okay, one of them is the root mean square of the residuals, RMSR. A rule of thumb, if it's less than 0.05, it's a good fit. So here we have 0.01, so our two-factor model is good. The degree of freedom corrected the root mean square of the residual 0.04, so that the RMSR adjusted for the model complexity is still less than 0.05, so it's acceptable. And then you have several other measures of factor score adequacy and etc. here. Okay. Okay. So if you want to say look into more information, so for example eigenvalues, or you want to create some plots, for example this scree plot for both the principal component and factor analysis, also indicating 2 factors is pretty good. Okay. All right. I want to move on to The second method, which is using nonlinear factor analysis, using a library called the HOMALS. Okay, we load that library, and it's very easy. We just need to feed the homals function with the ordinal underscore data, and then with n degree of freedom dimension equal to 2, with do 2 factors. And you must, this is important, you must do level equal to ordinal. Okay, and then you take a look at the structure of this output. So you can extract the eigenvalues, and then you can calculate, explain the variability, and then cumulative variability also explained at like 100%. Okay, and you can calculate the loadings, the factor scores. Now these are more in line with the traditional factor analysis. Okay, and you can get the objective scores. So these objective scores are really for provide the positioning of individual observations in the reduced dimension factor space, and you can kind of doing visualization for your clusters and all that. For example, you can plot out the joint plot, or the scree plot. A scree plot is really bad. I only get 2 factors here. But anyway, I just showed you 2 ways to do factor analysis of ordinal data, and we did not really go very detailed exploration of the outputs. There are many different ways you can look at outputs for more, for example, visualizations, and to look at the factor structure. Okay. Yeah, I would like to say factor analysis of ordinal data is actually not very simple, because we really need to think very carefully about the data generating process of ordinal data. So I just showed you 2 ways to actually you can get started with factor analysis of ordinal data in R. But if you are actually working on something really serious involving factor analysis of ordinal data, I strongly recommend you consult with someone who really understands the mathematics and technical details of factor analysis of ordinal data. All right. Thanks for watching.